আচ্ছা, এই রোদের কোনো অসুবিধা হবে না? Good afternoon, everybody.
Good afternoon, sir.
Good afternoon, sir.
I am you all. Am I audible?
Good afternoon, sir.
Yes, sir. You're audible.
Sir, you are
Yes, sir, audible.
Everyone is talking so much. I can't hear you clearly
I can't hear you.
because everyone is talking so much.
You just off your microphone. You can hear me. Okay.
Yes, sir, you are audible.
Okay. So we are just begin the workshop on chemistry, and especially we are using the materials whatever you normally get at home, and also some of the materials you can buy from nearby shops, very common materials. Now, first thing I'm going to start is that very simple thing. I think a very common experience to all of us is that normal days we have our food and wash our hands with water. Simply, it's clean, no problem. But when you are having your food, I mean the preparation with a very spicy and oily preparation you are having, after that, if you wash your hands with just simple water, would it be sufficient? It will be little bit oily, isn't it? Okay. Then what do you do?
Yes. It will be very oily.
It will be very oily, and then what you do is just put little soap, isn't it?
Yes. Yes.
You ever see? Did you ever see that whenever you apply soap, there will be a color change in your hand? What color it will? The color will be little orangish yellow or orangish red.
Yes, sir.
Why? Because whenever the cooking is going on, the cook is using turmeric in the preparation of the food. Okay.
Yes, sir.
This turmeric is available in every kitchen. Is a normal natural indicator. And what is its natural color? As you can see, this yellow. Can everybody see this?
Yes, sir. Yes,
Okay.
Yes, sir.
Normal turmeric, as you can see.
Yes.
Now, whenever you put little soap in your hand, it will change its color. Why? Because in soap there is base. So in the basic medium, this turmeric will change its color from yellow to orangish red or orangish yellow. That will depend on the quality of the turmeric, how much pure it is. Okay. Now let's do this step first. I'm taking a little. You can see this. In the spoon, I'm taking this turmeric in this transparent bowl. Can everybody see?
Yes.
Okay.
Yes. Yes, sir.
Was this much? Okay, fine. Now, putting some distilled water there.
What?
Sir, are we supposed to do the experiments along with you?
That is optional. If you like, you can do
What
it.
you
Or you send the
pour
material.
after the turmeric?
Water, distilled water is added to it, turmeric. Now, what color do you see?
Yellow.
Yellow.
Because distilled water is neutral, so we are getting the normal color of the turmeric. Clear?
Yes.
Now, what we'll do? Here, colorless soap solution. Can you see? This is absolutely colorless.
Yes.
Can anybody see color in this small beaker?
No, sir.
No, sir.
Yes,
No.
sir.
And
No, sir.
a simple dropper is fine. If you're nearby shop in the neighborhood shop, what I'll do, just watch it. I'll take one drop of this colorless washing, the liquid soap, which contains base, into this turmeric. Now, can you see the change in color?
No, sir.
Just a minute.
No, sir.
It will take more soap solution. I have to pour it. Now, can you see the change in color?
Yes, sir.
Yes, sir.
Yes, sir.
Which color is this now?
Orange yellow. Sir, red is.
Orange.
Sir, it is orange red. Sir, it is orange
Okay.
red.
So everybody can see the change in color.
Yes, sir.
Yes,
I can
sir.
see it, sir. Sir, it's orange in color.
Okay, fine. Now what I'll do, everybody has got this lemon, I think, fresh lemon. I'll apply one drop of this lemon juice from this lemon. Okay, now see. Okay, let me make it more. Now you can see it's absolutely orange red.
Yes, sir. I also did it. Sir, can you see this?
Now what I'll
Yes,
do,
sir. It is absolutely orange shade.
yes. Now I'm pouring this lemon juice from this piece of lemon. You can see gradually again this color is coming. What's color? Again it will back to the neutral medium.
Yes,
and
sir.
we're going to see the yellow color of turmeric.
Sir, can you see this? I also did it.
Okay, fine. Thank you very much. Okay, now can you see? Again it has turned from orange yellow to yellow again. Can
Yes,
you
sir.
see?
It turned again. I did also.
Now, if we apply more lemon juice, means now it is the neutral medium. We can see this yellowish color, the natural color of turmeric. Now I'm applying more of lemon juice, means medium will be acidic in nature. Now you can see very faint change. You can see the side far edge of this solution. You can find it is greenish yellow. It's
Yes,
become
sir.
it is greenish yellow. Can you see?
Yes, sir.
So
Yes,
this is
sir.
the color of turmeric in the acid.
Sir, my one is also greenish looking. It is also looking like green. Sir,
Greenish
yellow.
Did you get that greenish yellow color?
Yes, sir. I got the greenish yellow color.
Okay, fine. So this is the color of turmeric. Okay, got it?
Yes, sir.
Yes, sir.
Fine, thank you. So the first experiment is over. Now I'm proceeding for the next one. Okay.
Sir, greenish yellow.
Just wait. I'll arrange for the next one. Well, now you all know about this edible soda.
Yes, sir.
Yes,
Okay, now edible soda.
Yes, sir.
Chemically, what do you call it? What is its chemical name? Edible soda?
Sodium bicarbonate.
Sodium bicarbonate.
Sodium bicarbonate. Sodium bicarbonate.
Sodium bicarbonate.
Bicarbonate.
And also
Sodium bicarbonate.
Okay,
Sir,
fine.
NaHCO3 sodium bicarbonate.
You all know, I know. Okay, now what I'm going to do, and also you ask him, mummy will find they're using white vinegar for softening meat, isn't it? So we have this white
Yes, sir.
vinegar, and vinegar means containing an acid. What is that?
Acetic acid.
Acetic
Acetic acid.
acid.
Acetic acid.
CH3.
This is acetic acid.
CH3COOH.
Absolutely.
Sir, CH3
Okay,
COOH.
now I'm going to pour a little of this white vinegar into this. Find it. Narrow mouth bottle. Can you see? Narrow mouth transparent bottle?
Yes, sir.
Okay.
Yes, sir. Sir, I've already poured it.
Acid plus
Okay.
base plus what?
Now what I'm doing is that I'm taking a balloon here and pouring the edible soda powder.
So the result will be the balloon will be inflating.
I don't know. Let's see what happens.
Right. It will be inflating with carbon dioxide.
Because carbon dioxide will be
Reacting.
produced
Carbon
and it will
dioxide will
inflate
be
the balloon.
yeah.
The gas begins to expand in the bottle and starts to inflate the balloon.
This reaction is in our book.
Effervescence will be observed.
Yes. You have already read in your book.
We've done it in class 5. 4. We've done it in class 4. This experiment.
Edible soda within this balloon. Okay. Fine. Now, what I'm going to do, I'm just sticking the mouth of this bottle. Can everybody see? Can everybody see me? What I'm doing?
Yes, sir.
Yes, sir.
Yes, sir. Yes.
Okay, now I'm just taking this end of the balloon to the up and edible soda and the sodium bicarbonate inside the balloon that will come in contact with this the
It's
vinegar
working. See, sir.
carbon gas.
Sir,
Gas go and it will be contained within this balloon. It will be inside it. Isn't it?
yes, it's happening, sir.
Yeah. Can you see? The balloon has already been inflated.
Sir, brisk effervescence is taking place and carbon dioxide gas is evolved. So the balloon is going up.
Yeah, sir. Our experiment is happening. Out of the room.
Now, it just missed the balloon, all the gas is out. And I'm going to do the experiment once again. Okay?
Sir, can you see this?
Yes, sir. Sir, see, I did it, sir.
You did it fine. Excellent, excellent. Now I have little work that is left. I'm going to do it again. Okay, just watch it. Again, cameras is evolving and inside the balloon and it is there. Fine. Now, what else I'm going to do with this? I'm taking it out. I have to be careful this time, isn't it? First time I missed.
Sir, I have also created a balloon.
Yeah. I mean, next step.
Sir, we can also do it with the elastic gloves.
We can use anything which is rubber which can extend
Yes.
easily.
What I'm going to do is that I'm going to light up the candle there. As you know, we have everybody know carbon dioxide has been evolved, right? So the reaction was like this: CH3COOH, that is the vinegar or the acetic acid, reacting with this baking soda or the edible soda, that is sodium bicarbonate, and we are getting this reaction, that is sodium acetate, CH3COONA, sodium acetate, water and carbon dioxide, that's going up. That is inside the balloon. Now, we all know about this. One special property of carbon dioxide is, what is that? It's helping in extinguishing fire.
Yes, sir.
Yeah. So, what I'm going to do, I'm lighting this candle. So, candle is on. Everybody can see me?
Yes, sir.
Yes,
Okay,
sir.
now
Yes,
I'm
sir.
just taking the balloon closer to the flame. Just see. Boom. It's gone. And the flame extinguished. Can you see?
Yes.
Yes, sir.
Property of carbon dioxide. Helping in extinguishing fire. Okay. Now I'm proceeding for the next one. So, can everybody see me?
Yes, sir.
You can see this beaker, and there is a glass, and there is a raw egg. Okay,
Sir, it burst. Sir, it burst.
it will burst. Okay. Let's see.
Yes, sir.
Now, what I'm going to do, I'm pouring again this vinegar, white vinegar, within this
That
glass.
the acetic acid in the vinegar like eats up the calcium in the eggshell.
Now, can you see some bubbles? You can see.
Sir, I can see.
Yes, sir. It's forming white bubbles.
Yeah, bubbles are coming up.
Yes,
Now,
sir.
how is it formed? Can you see these bubbles within this acetic acid in the glass, and in the is filled with bubbles? Can everybody see?
Yes, sir.
Sir,
So how it's happening? Because in again, acetic acid there is in the vinegar, and
So the acetic acid like eats up the calcium in the egg and only the membrane inside it remains, which makes the egg very bouncy.
this is the reaction. This is the reaction happening there, and as you know, the reaction is like this: calcium carbonate in the shell of the eggshell. This vinegar is forming calcium acetate, CH3COO whole 2Ca, calcium acetate, water and carbon dioxide. Can everybody see?
yes, sir.
Okay. Now it will take long time.
Sir, why didn't the balloon melt when it was Sir, instead of eggshell, we could also use chalk.
Okay. Now see, it is a very slow reaction and it will take long time to complete the shell. Now, yesterday,
We should keep the egg in vinegar for minimum 1 day.
Time it will take.
this egg in this
It will become bouncy.
acetic acid. Now see, all the shell are equally enough. So all the whole cell made of calcium carbonate reacted with.
Sir, instead of an eggshell, could we also use chalk?
There is another form of calcium carbonate. That is a separate thing. You can see this egg.
Yes, sir.
Can we press? Normally, if you press it, it will just. What will happen? It will just click, and the liquid part will come out.
Spongy.
But here it is
Very bouncy.
because the whole shell part that has already been reacted with vinegar and it has been formed that calcium acetate over there and carbon dioxide evolved. Now you can see the reaction is going on here also. It will take long time to complete the reaction. You can say overnight reaction should be needed there to get the whole of this shell to complete. Okay. Now,
Can you drop the other egg on the table? It should bounce.
it may just come up little this. What is that other egg? Okay.
It
Now you
might burst on the table and it will make a huge mess.
absolutely. Even if no, it was just you can see the shell is over. It's inside this vinegar. This cholesterol part and the fat part is there. Okay, fine. Next. Now, I have some different materials with me. I have little boiled potato with me. Okay. I'm just taking out the skin. A little part will do, no problem.
Sir, what is that?
Boiled potato. Okay, fine. It will do. So this is boiled potato I'm taking and smashing on this plate. Can you see me? Can everybody see me?
Yes.
Yes, sir.
Yes, sir.
So this is smashed boiled potato. Can you see?
Yes, sir.
Okay, now I'm taking little rice. And
bitter gourd.
And the table and
Bitter gourd.
bitter gourd. Okay, have with me. Fine. So this is rice. Okay. Now here I have some bitter gourd with me. Boiled.
Yes, sir.
I'm just again, it's smashing it there. Like a beach stone. As you know, this egg white, okay, egg white I'm taking.
Sir, what will we do after that?
You just wait, I'll show you.
Sir, he
Sir, we
will
will put some drop in.
sir, he will add
Like that. And another part I'm taking this inside fatty part. Okay? Everybody can see all these 5 plates?
Yes, sir.
Okay.
Yes, sir.
And I think normally when there is a cut, body we use Dettol, Savlon, another thing. Can you tell me? Betadine. So I have this Betadine solution. It is also used in hospitals. This
Yes, sir.
antiseptic solution.
Yes, sir.
Okay.
Sir, we have to smash the bitter gourd.
Yeah, that then only you can get the results properly. Okay. Now before that, I have to do one thing. What is the actual color of this iodine solution? Now see, I'm taking a little water.
Red.
I'm taking a little water. Can you see
Red.
in this test tube?
Yes, sir. Yes, sir.
One drop of this iodine Betadine solution.
Brown, I think. Color is brown. The color should be brown, I think. Or
So
red.
after putting it in the solution in the potato or rice, it will turn into blue-black.
Can you
What
see
did
this?
you add?
This
Water.
is
Yes,
color
sir.
of Betadine in distilled water. 3-4 drops of Betadine in distilled water within this test tube. So this is golden or little orange color. Okay, can you see?
Yes, sir.
Okay, so this is the original color of Betadine. Okay.
Okay.
So what I'm going to do? Now first I'll give 1 drop to this, say, fatty part of the egg. What color do you see on this egg part? Fatty part of the egg.
Sir,
What color can you see?
brown. Sir, brown.
Brown. It's brown. There's no color change.
There is no color change.
There is no color change.
Sir,
Okay.
the color is not blue-black because it has protein. That's why.
Do you see this is blue black?
No. It is not blue black.
No,
No.
it's a egg white. Now I'm using egg white and putting this iodine Betadine solution containing iodine. Now, what color? Any change in color? Any change in color? You find
It is blue.
The brown.
brown is
Brown.
no change in color.
Little change in color.
Let me be a little more. Okay, so there is almost no change in color.
Yes.
Now, okay, done. Now, okay, let's take ice.
Blue black in color.
See, Can you see this bluish black?
Yes, sir.
Blue is black. Right.
The change in color of betadine?
Yes, sir. Blue star.
Okay. Now
But
again
because
you are
star is
taking
present in it.
this Butago. Butago, I'm putting this, pouring this betadine solution. Is there any color change?
No, sir.
No color change.
No color
Yes,
change.
Okay. Now at last, I'm going to take this
Potato.
potato. Yes, again.
Blue black.
No black. Yes.
Color changing from orangish to blue black.
but
Okay.
because of starch
Can
present
everybody
in it.
see?
It starts.
Yes. Yes.
This is due to the presence of starch.
Yes. Obviously, this rice and potato containing starch. The
Yes.
other items are not.
There are stars,
We have
right?
iodine.
Now, what's happening there? The
Stars.
starch containing two types of glucose, amylose and amylopectin. Amylopectin. Now, this amylose is responsible for the blue black color in the structure, helix structure of amylose. This atom has been trapped. So, we can. That's why you can getting this blue black color. Thank you. Now for the next one. For the timing one. Well, next. So I have a spoon. I'm taking a little bit of this table sugar. Can you see table sugar?
Yes, sir.
What color? As you all know, this crystals having what color? Whitish.
Whitish.
White.
What color? You say?
The white color.
Okay, now what I'm going to do? Lighting up this candle. And you can see I just place I'll just place the spoon over this candle flame. You'll see what change is going on.
Sir,
It will change into black.
sir, it is slowly
Sir, I
changing.
was starting and it has changed into
It
yellow.
will change into black. No. For the presence of carbon dioxide.
So it has turned into black color.
Let me fix it on the table.
Caramel color. Reddish. That's changing into reddish.
Now
Sir,
let's see what happens.
first
I will
brown, then black.
here. Let's see.
So it has formed into caramel.
Yes, sir, changing into caramel.
because very slowly you can see it's getting brownish. Can everybody see?
Yes,
The
sir.
color
Yes, sir.
is changing. Yes. What's happening in table sugar? There are impurities along with these water molecules. So when they are heated around say 190 to 200 degrees centigrade, the different. I mean, in table sugar, what's happening there? There is a sucrose, and when at the temperature it's decomposing into glucose and fructose, and as I'm continuously heating it, it's forming different compounds along with these impurities and water in the molecule. And this process is this browning of sugar is process known as caramelization. Okay, and the product of the process is carbon dioxide and water vapor. Ultimately, it will become carbon. It will be absolutely black. Okay. Okay. Now,
Let's see, this is becoming. There's a red.
yeah, here you can see this deep brownish color. If you continue making, it will ultimately become black. Carbon. Well,
It will also give us water in the form of steam.
now the next experiment I'm going to give can't get you. Okay. In the next experiment, what I'm going to do, I'll take little limestone powder. Chemically, this is calcium oxide. Little bit limestone powder I'm taking. Soda too. I'm pouring in distilled water. Yes. Mixing it properly. Okay. It will take little time. Now what I will do, I have to, you can see this is totally milky white. Now from this, I need the clear liquid. So I have to filter it. At home we don't have filter paper. What we are going to do, we will make use of the old newspaper.
This is lime in water.
Limestone in water, yes. Okay, now this piece of old newspaper I'm taking.
Sir, can you repeat what you did with the limestone powder?
This is milky white, yeah. This is milky white. I am going to get a clear solution from this milky white solution. For this, we need to filter the liquid, and we don't have filter paper at home, so we are using this old newspaper. I'm keeping a plate at every home. This is available. Keep the plate in the reverse way on the piece of paper and make the round. Well, now with the help of this scissor, I'll make a round shape, round piece of old newspaper, which will act as the printer paper.
Sir, can you repeat the steps? I couldn't understand.
Okay, I've taken a piece of old newspaper, kept one simple plate, along it comes with a T curve, inverse on the paper, make a round shape with a pen or pencil. Now I am cutting this round piece of this old newspaper.
Sir, done.
Okay, done. Let me do it then.
Sir, done.
Okay.
Sir, I have also done.
Okay, limestone powder, you'll get it in the hardware shop. Limestone powder, you'll get it in the hardware shop. Okay. There is also a question in the chat box. Okay, there was a question in the chat box where you can get the limestone powder. You can get it in any hardware shop. You'll find it.
Yes, sir, we can get it.
Sir, can we get it from a shop where we can get detail leaves?
Where you can get which thing?
Can we get in pawn shop?
Pawn shop. If you can get it from there also. Okay. Normally they don't. I mean, I couldn't find from a pawn shop because they didn't like to keep their limestone mixture. That's the mixture. They didn't give it and collect it from the hardware shop and make the solution. Okay, now this round shaped piece of paper from the old newspaper is ready. Now what I'm going to do, just look at me, I'm folding it as a semicircle. Can you see? Can you see this?
Yes, sir.
Now, I'm again folding under, making another fold of it. And now you can see this one part and the other part. I'm putting one finger in one part and placing it within the funnel. This funnel is available at every home, isn't it? Okay. Now I'm putting little water so that it sticks to the side surface of the funnel. Well, now I'm taking this. You can use this type of bottle also, where you can place the funnel. Now I'm pouring very slowly this liquid mixture and find it. There is nothing inside this small conical flask. Gradually, I can pouring the liquid. Yes, I'm pouring the liquid over here. You can see this is the mixture, hazy.
Sir, can you again tell me what we have to do after cutting the paper? With what will we make the filter paper?
What will we take this panel?
Instead of filter paper, we are taking this old newspaper. You can see.
Sir, can you repeat again that what we will do after cutting the piece of paper?
Yes, after cutting the old newspaper in the round shape, fold it, make a four fold, first semicircular, then one fold. Got my point? Okay, let me show you once again. Let me do this step once again. Okay. Now you can see, first you can see the here, one by one drop is coming out of this funnel. And that the drop is filtered through this old newspaper. Can you see?
Yes, sir.
You can see one by one drop.
Yes,
Remaining.
Yes, sir.
Yes, sir. It's clear.
Okay, just showing the previous step once again. Suppose this is your round shaped, that old newspaper, you just fold it in the semicircular way, then make the second fold. Okay? Now, this is two part, this is one, and this is two. Put one finger in the one part, then in this way, you place it in the funnel and put little 2 to 3 drops of water so that it can stick with the inside surface of the funnel. Got it, everybody?
Yes,
Yes,
sir.
sir.
Okay.
Yes,
Yes, sir.
Okay, it will take little time because gradually, drop by drop, it's coming.
Sir, it's coming very slowly.
Yeah, it's not a normal filter paper. We are just using the old newspaper there because this is little porous compared to the other papers. More porous compared to the other papers. So we can use this newspaper. Continue. Can everybody see drop by drop? This clear liquid is coming.
Yes, sir.
Yes, sir.
And let me show you the reaction. First, we have taken this calcium oxide, means limestone powder, mixed with water, and we are getting this calcium hydroxide. This step we have already done. Now the second step, it's not done yet, because when the liquid will be clear, liquid will find it, then only you can do this.
ওইটাই বোধ কপারের সাথে
Now see the liquid is coming, that is absolutely clear.
Powder and the mentioned limestone powder in the
Yes, sir.
funnel.
Please talk one by one. I cannot understand anybody.
Sir, I can see water instead of limestone.
This is water-like liquid, not water. Mind you,
I
this
can
is,
see the filtered water.
yes, clear water like liquid you can find now.
Yes,
Yes,
it's
sir.
clear water, sir. It's clear.
It's clear.
It's the
That's right.
clear water
But
with
it is not.
filter.
It's water-like, but not water. Mind it. It's a clear solution of calcium hydroxide. That's the filter.
Yes.
Well, what I have to do, let's see. Let's proceed for the next part.
It's taking a lot of time.
Yeah, it will take a little bit time. Okay, let's see. Let's try this. Well, so this is clear solution. Can you see? Can everybody see?
Yes, sir.
Okay, now what I will do? Yes, I have a straw with me. Now I'll blow or exhale air. So initially it was clear solution, isn't it? Now see what's happening. Can you see I'm blowing?
Yes, sir.
Yes, sir, you are giving.
So can you see? Is it clear now?
No, sir, it has become,
No, sir.
It's not at all clear now.
sir, it has become milky.
It's again becoming milky.
Sir, because there is formation of calcium carbonate. It is a white precipitate.
So this is the second reaction. Yeah, and as I'm blowing, the exhale air is going to it. So calcium hydroxide plus carbon dioxide containing the most in the exhale air, and we are forming this calcium carbonate and water. And this calcium carbonate is insoluble in water. That's why we are getting this milky part again. Okay?
Yes, sir.
Yes,
Okay.
sir.
Now, now in this
Liquidator.
conical, you can see there is a 5-fitted cord. I'm pouring the edible soda.
Soda? Soda.
Edible soda.
Honey? Sodium carbonate.
Sodium bicarbonate. Edible soda, sodium bicarbonate.
ওইটা দরকার পড়বে Sir, what is a white powder?
This is, you can read edible soda. That is sodium bicarbonate. Okay, NaHCO3. Now I'm pouring this vinegar and the white vinegar within this. So again, you have already seen this in the second experiment. Carbon dioxide has formed then Again, carbon dioxide will form. So this was milky liquid. So carbon dioxide coming and mixing with this liquid, it was milky. Now see whether there will be any change or not.
Yes, sir. It is slowly become transparent.
Sir, can you repeat again, please?
Slowly, gradually becoming transparent.
Like it was before.
Yeah, that like it was initially. Will take little time again. Connection. Anyway, now the solution is becoming clear. So what's the reaction? You can see earlier it was calcium carbonate that was insoluble. Now, when more carbon dioxide we are pouring it along with water, it's forming calcium bicarbonate, CaHCO3 whole 2. That is soluble in water. That's why we are getting the clear solution again. Got it?
Yes, sir.
Okay, fine. Next. Suppose this is a spoon, isn't it?
Yes, sir.
Yes, sir.
You can see how shiny it is
Yes, sir.
because there is a coating of some shiny metal over this. Over say one iron, normal color one is blackish. So over this iron, this coating is there. Now, you all know whenever water is hydrolyzed, you can get hydrogen and oxygen. Now,
H2O.
this is the basic process, and by applying this process, you can use this process you can use as electroplating. And by electroplating, why this is used? This electroplating is used to protect the material from the corrosion, environmental corrosion, and also to beautify the material. What I'll do, you can see there is a key. Can you see?
Yes, sir.
No, color, earlier
I
color
don't
is golden, but now it is absolutely black. Now I'm taking little emery paper. I'm just rubbing the surface of the key.
Sir, is it transparent?
Sir, with what you are rubbing the surface?
I'm rubbing the surface with this emery paper or the sandpaper, so that only part on the surface will go away.
Sir, the dirt is getting removed from the key. The dust is getting removed from the key.
Yeah.
Yes, sir.
So this is going to be the last experiment, I think. Time is becoming already over, isn't it? I'm just continue with this last
Sir,
experiment.
it's becoming shiny. The key is becoming shiny.
It's becoming shiny. Yes, it's becoming shiny. Now, what I'm going to do, we have to keep one thing in mind. In electroplating, two things are there. One thing is by which material we are going to electroplate, number one, and number two is on which material we are going to plate or get the coating. By which material we are going to electroplate, we have to take 1 salt of that material as the electrolyte. For example, say we are going to plate with this copper plate. You can see the piece of copper over here.
Yes, sir.
We can also use this with this
Copper
copper ring. Normally find in many houses the old copper rings. And I'm again rubbing this surface of this copper plate.
Sir, I have a copper coin.
Okay, then rub with the sandpaper. But one thing I think there should be a hole like this through which you can.
Yes, sir, I have a hole. Yeah, I have a hole in it.
You have a hole.
Yes, sir.
Excellent, excellent. Carry on, please. Excellent.
But this is a coin.
Yeah. Carry on. Now what you have to do? So this piece of copper is here. Now this is here. And the surface that will be connected with the power supply, that has to be clear also.
Sir, can you take copper utensils, sir? Can you take copper utensils?
Yes, copper.
Sir, copper utensils.
Copper utensil is a big substance. You can also play with that, but there should be a hole or one animal should be there that you can keep it connected with the line. Okay, now let's see. So this is the copper piece by which we are going to plate the substance. And which substance we are going to plate? We are going to plate this key. We have already cleared it.
Yes, sir.
Okay. Again, you have to rub this end of this connecting part of this copper wire. Well, so by this end, I am connecting this key, golden key that is cleared by rubbing the surface. Can everybody see?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, now I'm connecting this end with this copper, with this key, and there is a hole within the key. You have to clear it first, mind it. You have to clear all the impurities over the surface. Otherwise, it won't act properly. So I'm just tying this copper wire with the hole of the key and very tightly. Okay. Now, one more thing is that the material by which you are going to plate, that should be connected with the anode of the power supply. Anode means positive electrode of the power supply. On the other hand, on which material we are going to plate, that should be connected with the negative electrode or cathode of the power supply.
Yes,
Now
sir.
let's take the got my point.
Yes, sir.
Okay. Aditi, how many of the
The
Yes, sir.
negative is anode.
Yes. Pardon?
Negative is anode.
Negative is
The
anode.
negative is anode.
Check it. Check it with your book. Negative electrode is the cathode and positive electrode with is known as cathode anode. Okay, I'll show you. This is my power supply, okay? Can you see this plus and minus?
Yes,
Yes,
sir.
sir.
For example, say the plus that is connected with this red wire and the minus that is connected with the blue wire.
The blue wire.
Can everybody see?
Yes, sir.
Yes, sir. Yes.
Okay. So this plus sign, this is anode, and I'm going to plate by copper piece. So I'll connect the copper piece with this red wire connected with this positive electrode. For example, say
Sir, is it a voltmeter?
okay, just a minute. You can see this red wire. You can see this red wire here,
Yes, sir.
and by which through copper wire it is connected. This copper piece is connected here. We all can everybody see?
Yes, sir.
Yes, sir.
Okay. Now this is the red wire. Now blue wire that is connected with the blue wire is connected with the negative electrode. That is the cathode. This is blue wire. The other part of the blue wire is connected with this key on which we are going to plate. Can you see this key?
Yes, sir.
And this is the blue wire. Blue wire. Can you see?
Yes, sir.
Yes, sir.
Blue wire along with this key.
Hold it a little up.
Yes, yes.
Sir, can you hold it a little?
Now you can see.
Yes, sir.
Yes, sir.
Okay. Now this blue wire is connected with this negative electrode. Okay. Fine. Now let me prepare the electrolyte solution. For which, as electrolyte solution, we are going to get the use the crystal of this known as blue vitriol. Bengali call it tute, or Hindi is called tutia.
Yes,
Do you
sir.
know?
Copper sulfate. Copper
It is used.
sulfate.
It is used. Yes, chemically.
Fungicide.
What is the other use? This is actually used for making adhesive,
Copper sulfate.
binding of books,
And
and
fungicide.
so that it can be protected from the insects. And now, one thing I must say to you all, please keep it in your mind. Whenever you are doing work with all these type of materials, you must, after work is completed, you must wash your hands properly and clearly. Got my point?
Yes, sir.
Everybody, wash your hands clearly. Okay. Now with distilled water and making the solution. So I'm just preparing the electrolytic solution of this blue vitriol or toothia or toothate or copper sulfate. Since it's a salt, it will be ionizing the solution in copper ion, cupric ion, Cu++ ion, and sulfate ion, SO4 2- ion.
Yes, sir.
And the positive ion will be attracted towards the negative electrode, and the negative ion will be attracted towards the positive electrode, as you all know.
Yes, sir.
এখানে বাবল হবে, সেটা কি দেখানো যাবে? Well, my solution is almost prepared. Now what I'm going to do, I'm switching on the power supply and keeping the voltage say about 9 volts. Okay, and putting this copper means connected with this red wire, mind it, red wire. So connected with this positive electrode means this is anode, and this key is connected with this negative electrode. And see, with this blue wire, it is the cathode, connected in the cathode. And you can see initially the color of it was shining with almost golden color. Let's see. Get ready, everybody. I'm just taking out the key from the solution. Are you all ready?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Earlier, the key was almost blackish with dirt. I've cleared the dirt with emery paper. So then it's become shiny. Now it's poured into this electrolyte solution, and now I'm just taking it out from this solution. Now see whether there is any change. If there is any change, what type of change? We একটা সাদা কাগজ তো ব্যাকগ্রাউন্ডে রাখি।
So it's become blackish.
Yes, this is actually the deep brown color of copper. Can everybody see
Sir, deep brown color. Sir, deep brown color.
deep brown color of copper? Because copper is coming from the solution and keeping on the in the surface of this key. I'll give you the reaction. Okay.
The iron got displaced, I think.
Now, first the electrolyte solution will be ionized. Copper sulfate will be ionized in copper ion, Cu++ and cupric ion and the sulfate ion. Well, this cupric ion and the sulfate ion is ionized. Now, at the cathode, what will happen? This copper ion will be attracted towards the negative electrode. It will lose electron and it will be deposited on the whichever material is kept in the cathode. So key was kept on the cathode, so copper will be deposited on the key. And since there will be lesser amount of copper ion in the solution, in the anode, copper will leave 2 electrons, and as copper ion, cupric ion, it will come into the solution. Okay, got everybody?
Sir, can it be replaced with gold?
Yes.
Sir, can it be replaced with gold?
Yeah, can obviously it can be replaced by gold, but gold is very, very, very costly nowadays, you know. Okay, so since copper is available, we are just showing you the process, how it is done, how the cross-regulativity is done by copper, and on the key in the cathode on which the plating is done. Okay, so this is the reaction, and for today, thank you everybody for joining us.
Thank you, sir.
Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you, sir. Sir,
Everybody,
you gave us so much knowledge. So we learned a lot from you, sir.
We learned and enjoyed very much.
We also enjoyed too, sir.
Thank you, sir.
We learned a lot and enjoyed very much. The most exciting one was the fasting one. That's the most exciting one.
just forgot to tell you one thing, that this material, blue vitriol, this is little poisonous, maybe. That's why I told you, you always wash your hands clearly after using this, and it will be available in the Doshakarma shop, the shop where the materials for puja, for worshiping God is there. There only you can find big shop, not the small Doshakarma shop.
Yes.
Okay, and I'll give you my email address. Already I think you have. So this is my email address. Whatever your feedback, you liked it or you didn't like it, please let me know in this email address.
Sir, I liked it very much.
Please give it in my email address, okay?
Yes,
Okay,
sir, of
sir.
course, I will give it.
Okay, sir. My email address is Kanishka9, KANISHKAA9 @gmail.com. Got everybody?
Yes, sir.
Okay. Actually, in whatever email address you got the link, from which address you got the link, then in that address only you send your feedback. Okay?
Sir. Okay, sir.
Thank you very much for
Thank you, sir.
having time with you.
Thank you, sir.
Okay.
Thank you, sir. Thank you, sir.
Thank you very much. Thank you.
Sir, this is the first time I'm seeing you, sir.
Okay.
This is the very first time I'm seeing you.
Very first time saying me. Okay, that's not the problem. How did you enjoy the program? That's the question. Did you at all enjoy?
Yes, sir.
Yes, sir.
Sir, I enjoyed a lot, sir.
Okay, please give me the feedback whether you have liked it or you don't like it. Okay, please give me the feedback in the mail address from where did you get the link of this meeting. Thank you very much. Thank you all.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Most welcome. Most welcome.
Thank you, sir.
In coming days, we're going to arrange some more workshop. I think. Get ready. Thank you.
Sir, is